The Leave Plan of Room specialist has found that using our new 101 billion toy, it will be plainly reliable before that give changes into a reality, a shot at the remote likelihood that it goes as coordinated. The excursion to Proxima B will expect right around 20 years, so sensibly it will be a couple of years sooner before we can interest, assuming there is certain life on that planet. The spread-out arrangements of whether we are really alone in this universe move beyond the James Webb Space Telescope, which has discovered some astoundingly human things far away from Earth that lead us closer to the response. Our central objective, generally beyond us, has been uncontrolled throughout every human activity, so much that we have innumerable media works and speculations concerning this matter. Our wonder concerning our spot, what's more, horror in the universe has been consistent. It is drenched inside us to look constantly for a mate, paying little regard to how fragmentary we might be. We might get progressively nearer to the responses we really need. Anyway, are they truly the responses we are looking for, or are they just really upsetting? Oblige us as we separate the most recent discoveries in the space of frameworks and planets on the outing to track down something we most likely cannot see. Lights far away, trained experts have found what could be the most significant openness in history back in 2021, when the James Webb Space Telescope was planned to deliver off an uncommonly fascinating theoretical. A requesting was raised about the limitations of our improvement. The solicitation was whether, later on, our telescopes could perceive artificial light on another planet, for instance, Proxima B, the closest exoplanet to Earth. Proxima B, around 4.25 light-years away, was perceived to be impeccably locked with a particularly strong day side and night side, like our moon. A hypothetical imaginative improvement for Proxima B could move power and energy from the day side to the evening side using photovoltaic cells that make power from starlight. Therefore, in a paper with Manisving as one of the science-educated authorities, it was shown that a giant gathering of the day side by solar chargers could be connected with future telescopes. Since JWST was also developed, it would allow us to extend our mission for artificial lights on exoplanets like Proxima B. Now, the truth that the James Webb Space Telescope did exactly that in 2024, using its higher consideration and greater degree of capacities, is significant. The JWST could have found the lights we were looking for and maybe flung us into another huge surge of human development. By what's more, enormous, we should dive into the universe of planets and exoplanets to figure out how this was no uncertainties and/or buts even possible. James Webb's mission explores Proxima B and Proxima B secrets. Beginning from the beginning of written history, individuals have considered the chance of the universe. What we are, where we come from, what's more, where we go. These are custom, however staggeringly abnormal deals that humankind has tried to answer. At the moment that we got care in the hour of amazing mechanical movement, one ponders whether we are any closer to seeing these arrangements. On the off chance that you, somehow, figure out how to ask a scientist, he could say we are as of now at level 0 of sorting out ourselves in the universe. Notwithstanding, ask a space expert something comparable and watch him take full benefit of his energy as he rushes to let you know the most recent openness individuals have made about the universe utilizing their shrewd contraptions. These instruments, however not exactly contemplated by the overall populace, are clearly an impression of human activity itself. We at present have the world readily accessible, and it's time we push forward, also, get the universe within our scope. One such technique for doing so was not entirely set in stone by scientists and space experts through the development we tackle. A specific creation of that advancement is now dependable for the new discovery of what might be light on another planet, light years away. For sure, we're discussing the James Webb Space Telescope. The James Webb Space Telescope is the creation considered out of the practices of human undertakings into space to address some ever-present questions. Are we just us? Who's out there? Where do we start, and where do we end? This infrared space science contraption has as of late begun paying exceptional attention to these arrangements, not getting through the reality that, at first, you could get yourself asking what Proxima B is. Proxima Centauri B, or just Proxima B, is sometimes alluded to as Alpha Centauri B. It is a super-Earth exoplanet and circles an M-type star. Super-Earths could dumbfound you, but don't stress. This text will settle all your burning inquiries. Super-Earths are a class of planets that are more significant than Earth but lighter than ice giants like Neptune and Uranus. They are truly one of a kind. They can be made of gas, rock, or even a blend of both, and their sizes can vary from 2 times the size of Earth to a couple of times its mass. With respect to Proxima B, it is a super-Earth and an exoplanet, implying that it circles outside the nearby planetary system. The principal possible affirmation of an exoplanet was found in 1917, but it gathered essentially no interest. However, affirmation came in 1992 with the first confirmed discovery, which left specialists flabbergasted. Another exoplanet first saw in 1988 was affirmed as a prescription in 2003. As of April 1, 2024, there are 5,653 confirmed exoplanets in 4,161 planetary systems. Of these, 896 systems have more than one planet. These apparent discoveries are surrounding an M-type star. To comprehend the M-type star, you really need to sort out the red dwarf. Red midgets are the smallest kind of star in the principal arrangement, hence the name. In the interconnecting region of the Sun, red diminutive people are by far the most notable type of star viewed in the Milky Way. They have remarkably low splendor, and since brilliance is one of our essential tools for planet affirmation, red smaller people are not easy to see. These unpretentious stars have variable definitions and names depending on their temperatures and sizes. For example, more minor individuals, or M-type main sequence stars, yield a maximum temperature of around 3,000 K, subsequently getting their name. As for Proxima B, its mass is known to resemble 1.07 Earths. Strangely, it just requires 11.2 days to complete one circle around its star, contrasted with our 365.25 days. You can really check the size of the star, Proxima B. It is incredibly under to encompass it. The assessment of the entirety of its electromagnetic reach is that the star has a general brilliance of as little as around 1.6% that of the Sun. Other than in the noticeable light range, its splendor appears to decrease more. It just sparkles 5 to 6% of the Sun's brightness, radiating a much lesser sum of light energy compared to the Sun. More than 85% of its transmitted energy is infrared radiation, pivoting around about 0.045 to 0.056 cosmic units from its star. Proxima B's revelation was accounted for back in 2016. You could inquire as to why Proxima B, with 1 million stars, planets, and universes, is of such obsession. Well, there are a few reasons that add to the prominent interest cosmologists have here. Specifically, Proxima B is the closest known star to our Sun and, by definition, although 4.2 light-years is a huge number to us Earthlings, in the grand plan of the universe, it is a reasonable blip. Thus, Proxima B, our closest realized star, is high up on the priority list right now. It is part of the triple star system called Alpha Centauri. Additionally, not enduring Proxima's brightness being unbelievably low, the actual system appears as possibly one of the most brilliant, glorious bodies in the night sky, just behind 2 others called Sirius and Corvus. Anyway, the most overpowering thing about Proxima B is that it could really be tenable, as it falls inside the habitable zone. The potential results surrounding the star are boundless, and subsequently, space experts have acknowledged the task of exploring the profundities and limits of the star's legitimacy. That is where the James Webb Space Telescope comes in. The 4 crucial targets of the JWST are to look for light from the initial stars and universes that formed in the universe after the Big Bang, focus on the universe's plan and progression, sort out star and planet development, and spotlight on planetary frameworks and the beginnings of life. As the JWST continues its evaluation of the said exoplanet, we draw closer to the most essential piece of these missions, from searching for exoplanets to looking for extraterrestrial life. So, what precisely is in question, one could inquire. Taking into account that humans have endlessly been a curious species, examining and getting into literally all that moves and doesn't move, it seems sensible that a mission like SETI showed up on such a huge scale. Imagine that God has framed an unfathomable, immense undertaking, but with a sprinkle of gold, we are tasked with being careful for signals, more specifically electromagnetic murmurs from human developments, past whatever we might at any point imagine. SETI, short for the Search for Extraterrestrial Intelligence, seems to be the world's most high-stakes round of Find the Stowaway, with our planet as the searcher and the colossal universe as the seemingly endless hiding spot. It's one of those fields where specialists are like high-level Sherlocks, tuned into radio waves and scouring for that subtle "we are not alone" sign. This giant search began during the 1960s. Frank Drake, an outstanding astrophysicist, was among the first to recognize radio transmissions from the stars. It was a critical moment. However, no extraterrestrials appeared at his door. Now, as you would have speculated, looking for something this gigantic takes patience and can span an enormous number of years. Long stretches of work sometimes elapse without finding anything conclusive. A few undeniable alien signals have been found, but in spite of these efforts, the energy continues to grow as the James Webb Space Telescope continues evaluating exoplanets like Proxima B. A whole field of hope is emerging. Will we accidentally find real evidence of extraterrestrial life? Or will we just encounter confusing signals beyond our ability to understand, giving us more questions than answers? The discovery of signals could mark the next phase of humankind's unfading interest, where curiosity and exploration blur into one huge, exciting space story. So, let's keep looking, hoping to find affirmation that we are not actually alone. The discovery of signals from faraway exoplanets, like those potentially seen on Proxima B, could be a striking move toward answering one of humanity's most critical questions. Are we alone in the universe? As the James Webb Space Telescope continues to survey the skies, its discoveries will undoubtedly spark more conversations, debates, and maybe, indeed, even challenges to our key understanding of life, intelligence, and the nature of the universe. The repercussions of these discoveries reach far beyond basic curiosity. They carry the potential to reshape our philosophical and scientific frameworks. For instance, if we somehow happen to confirm that Proxima B or another exoplanet harbors life, it would drive us to re-examine our position in the universe. Could life elsewhere evolve in ways similar to our own, or would it present a completely new type of existence? Would it follow identical evolutionary pathways, or would science and awareness challenge all that we know about life on Earth? Regardless of whether we fail to find immediate confirmation of intelligent life, the simple fact that we could detect artificial signals or lights from distant worlds would still have significant implications. It would essentially mean that there are intelligent civilizations out there, hypothetically capable of altering their environments in ways that become visible from our vantage point. This would affirm that intelligent life is not a rare anomaly, but rather may be an inevitable result of specific circumstances in the universe. In any case, it's essential to stay grounded and mindful in considering such discoveries. While the potential for finding life is exciting, it also raises the question: what happens next? How will we respond to the confirmation of extraterrestrial life? Will we approach it with respect, curiosity, and scientific rigor? Or will the discoveries spark chaos, fear, or even political conflict? History has shown that humans' reactions to new revelations, especially those that challenge deeply held beliefs, can be unpredictable. We should also consider the moral aspects of our curiosity. If we do find evidence of life, particularly intelligent life, what does this mean for our responsibility as stewards of our planet? What moral considerations should guide our interactions with other forms of life, whether microbial or advanced? These are not questions that can be addressed easily, and they will likely be a central part of the conversation as we venture further into the universe.